So we're going to start talking about the unit circle, and there's a lot of values in here. We're going to kind of build it as we go, so that you understand where everything comes from. And then, if you were ever stuck out in the desert and you didn't have access to the internet and you needed to come up with some sines and cosines, you could come up with the unit circle from scratch. It's happened to all of us. Basically, where this comes from is, and the way it gets its name is, since we've been graphing in coordinate planes, let's look at this. So we've got this coordinate plane here. The unit circle, unit in math usually means like one unit. So we've got this coordinate plane. Each unit on here is worth 1. We go up to 5. So then the unit circle, that big circle, all lives right there. So that the radius of this circle is 1. And that means no matter where we draw a line, it's going to be equal to 1. And that's going to help us out a lot later when we start working with sines and cosines and stuff. And we'll talk more about that later. But back to our unit circle. So far we've really just talked about angle measures and things like that. So we're going to stick to that for now. So let's look at this unit circle. So let's start to fill in the things we know. We know that that this is 0 degrees, right? And we kind of just established that as a mathematical standard. We're just always going to start at 0 degrees at the positive x-axis. And that way, when mathematicians are talking to each other and somebody says 0 degrees, everyone knows what they're talking about. So that's kind of why that standard was established. So we know this is 0 degrees. I know that this is a 90-degree angle, right? So then that must be 90 degrees. We've looked at that a little bit. And then a straight line, we know that this is 180 degrees. And then down here, this is 180 plus 90, or 360 minus 90. And then we get back up here, and turns out 0 degrees is equal to 360 degrees. So we've got these points that we know pretty well. But let's break this circle down a little bit because there's some other stuff that I think we can figure out. So let's start with this line right here. So what I see is that is halfway from 0 to 90. That is exactly halfway through that first quadrant. This arch is the same size as this arch, so way you can kind of see that. So that's halfway there from 0 to 90. That must mean that this is 45 degrees, right? And let's look over here. Same thing here. And we've talked about reference triangles, and this is why. So this is, as you can see, this is very similar. It's the same distance from 0 to 45 as it is from 180 to this number. And likewise, it's the same distance from 90 to this angle than it is to 180. So once again, it's halfway. It's half of this 90 degrees. Therefore, it must be 90 plus 45, which is 135 degrees. You'll see that enough that you're going to remember that value pretty well by the end of this semester. So now we've got 45 and 135. Let's keep it going with these middle lines. They seem to be the easiest ones available at the moment to work with. And we'll do both of these. So in fact, this looks just like the way these are drawn now. You can almost just rotate this 45 degrees and you could see that these are all 90 degrees apart. Right? And then if you include the axis lines, they're all 45 degrees apart, right? But we can use that. So 180 plus 45, well, that's 225. 225 plus 45 is, oh, this isn't 90. Why did I write 90? This is 270. 180 plus 90 is 270. 225 plus 45 is also 270. And then 270 plus 45 is 315 degrees. And to check our answer, 315 plus 45 is 360. So as we can see, we've broken this circle into eighths, right? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Equal parts, and each angle is 45 degrees. Okay, so now let's look at another one of these. Let's look at this one. So if I draw this one, and then the one that corresponds to it is going to be the one that kind of reflects over that y-axis. So you kind of see the reflection there. So as you can see now what I've done, if you include, these axes, I've divided the top half of that circle into thirds. So the top half of that circle is 180 degrees, so 1/3 of that is going to be 60 degrees, right? 60 is 1/3 of the way there, and then you add 60, that's going to give you 120, and you add 60 more degrees and you get 180. So if we keep up with this pattern, we're going to take another one of the big chunks here, and then we'll add this chunk here. You kind of see that big chunk. Another third of the bottom half of the circle. So we're at 180, and we're going to add 60. That's 240. We're going to add 60 to 240, and that's 300. And we're going to add 60 to 300, and that gets us back to 360. So now we've got another way of dividing it up. So then we've got just one left, and that's these smallest lines here. So what I'm seeing here is that if I look at this line, and this line, they're all the same size. And I'm also noticing, so basically what I'm seeing then is this is 1/3 of 90. 1/3 of 90 is 30 degrees. So then this is 30, plus 30 is 60, 60 plus 30 is 90, 90 plus 30, oh, I did 60 here again. So that's going to be 120. Right? 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. 180 plus 30 is 210. 210 plus 30 is 240. Oh, I need to color the lines. 240 plus 30 is 270. 270 plus 30 is 300. And then 300 plus 30 is going to be 330. So for now, that's all we've really done. We've learned it with the unit circle. There are a lot of different ways to memorize this, and I might ask some of you to share them because I've heard some really good ones that students have come up with. If you were going to like try and make this from scratch, you could kind of just remember the add 30 rule, because that last one we did hit almost every single line except for the 45-degree ones, right? So if you started at 0 and you just added 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, you'd get almost all the lines. And then you just have to remember to go through and do a 45-degree one in between. I've heard people say, well, you start at 0 and then you add 30, then you add 15, and then you add 15 again, and then you add 30. And then you make a pattern out of that. So 30, 15, 15, 30. These smaller chunks are 15s, and then the bigger chunks are 30. So that's another real quick. So turns out that 0 degrees is the same as 0 radians. Big surprise. We also saw that, remember the definition is that half a circle is pi radians, so pi and 180 go together. And then a whole circle is going to be 2 pi, which is equal to 360 degrees. Right, so we've got those easy ones. Now let's kind of cut it in half. So halfway from 0 to pi is going to be half of pi, or pi over 2. And then down here, pi plus pi over 2 is going to be 3 pi. over 2. It's the same, like 1.5, right? 3 pi over 2. So those are the big corner pieces, and then let's fill in some of the smaller middle ones, right? So we've got this 45-degree one. We'll go in the same order. So 45 degrees. If you look closely, you can see that this is 1, 2, 3, 4, right? It's 1/4 of the whole circle. So that means that this is pi over 4. Sorry, not of the whole circle, of the half circle. So that's pi over 4. And then you add another one, and that's 2 pi over 4, right? Well, 2 pi over 4, you can simplify to pi over 2. So that's a nice way to check our answer. But we already filled that one in. Pi over 2 plus pi over 4, that's going to be 3/4 pi, right? 3 pi over 4. And then we add pi over 4 again, and we get pi. 3 pi over 4 plus 1/4 of pi is a whole pi. And then add pi to pi over 4, and you get 5 pi over 4. So now I'm just adding pi over 4 each time. 5 pi over 4 plus pi over 4 is 6 pi over 4, which simplifies to 3 pi over 2. 3 pi over 2 plus pi over 4 is going to be 7 pi over 4. And then we add one more, that would be 8 pi over 4, which simplifies. 8 over 4 is 2, so it would simplify to 2 pi. So that checks out. So now let's do our 60-degree one. We've got, let's see, we've got, this is about well, it is exactly, it's 1/3 of this whole half circle, right? So there's 3 of these light blue chunks in the half circle. So that means this is 1/3 of the half circle. It's pi over 3. And then you add one, this would be 2 pi over 3. And then you add another, that would be 3 pi over 3, which is just pi, because 3 divided by 3 is 1. And then we keep that going. 3 pi over 3 plus pi over 3 is 4 pi over 3. 4 pi over 3 plus pi over 3 is 5 pi over 3. And then you add another one. 6 pi over 3 is the same as 2 pi, because 6 divided by 3 is 2. And then the last one would be the 30-degree angle. So we've got, well, this is 1, 2, 3, 4, 5, 6, right? It's 1/6 of the half circle. And that makes sense, right? Because 1/6 of 180 is 30 degrees. So it adds up. So then this is going to be pi over 6, because it's a sixth of the half circle. And then you add pi over 6 to that, you get 2 pi over 6, which is the same as pi over 3. Add pi over 6 to that, you get 3 pi over 6, which is the same as pi over 2. Add pi over 6 to that, and you get 2 pi over 3. Add pi over 6 to that, and you get, so that was 4 pi over 6, so this would be 5 pi over 6. And then add pi over 6 to that, you get 6 pi over 6, which is pi. Add pi over 6 to that, you get 7 pi over 6. Now this would be 8 pi over 6, 9 pi over 6. These numbers simplify. And then the last one, well, this would be 10 pi over 6. And then this last one's going to be 11 pi over 6. And that is basically the unit circle broken down into degrees and radians.